Okay, hello, welcome to HeatingGeek. Today I'm just showing you an intermittent fault that I had on this Biasi. This has had 2 engineers, 5 visits. No one can work out what's wrong with it because the fault is so inconsistent. So one engineer saw the fault, but within 10 seconds it was gone. So this is the fault code, this is what the lights do, and this is the book. So we have the red light on in the middle, which would be a black dot, and the other 2 flashing simultaneously together, which here says it's a lack of burner ignition, no ignition signal from the full sequence ignition device. So I'd just like to point out, if you're not gas safe registered, you shouldn't be working on boilers because they are dangerous, and if you do something wrong you end up killing yourself or someone in your family. Don't blame me for your stupidity. Alright, it's working now. So this is the ignition control PCB here, main PCB there. If you watch my Vocera synthesis video, you'll understand that that PCB is basically quite dumb. It gets power down here on this connector here on the live closest to you. This gets power there, and then this is dumb. All it does is get that boiler to light. That's it. Doesn't know anything or do anything other than that. So the fact that we're getting the red light on and the other 2 flashing here indicates that the main board is telling the small board to do its job, and then the main board is recognising the small board isn't doing it and putting a fault on there. So what I need to do is catch it at fault and just test this board on the live closest to us. If that's got 240 there, this board should be making the boiler light. It's as simple as that. 10 minutes later. It's alright, it's doing it now. I'm going to get a test on it right now. Oh. I was jumping around because I had DC. So, we have 240 on them bottle connectors in there, which you can't see. I'll move that in a sec. So again, the main board is telling the dumb board to light the boiler. The dumb board is not lighting the boiler. So why isn't it lighting the boiler? What are the reasons for the dumb board not to light the boiler? Well, let's have a look what connects to the dumb board. Does it have anything that could hold it off? That's the very next thing we're going to check. Okay, we've got 240 on there. I'll show you what I'm testing there again. Let me try and get some light down here without it going all funny. That's where I'm testing it there, on that live and neutral, which is the most bottom live and neutral on that PCB. So let's try and see now what on this little PCB could hold it off, and I'm going to tell you now, 9 times out of 10 it is this little PCB. So it's also made by 2 different people, this PCB. This one is made by Battalion Partners, which says it there. This one is made by Battalion Partners. There's also a Honeywell version of this PCB. They are interchangeable, so that's fine. They often burn out there on that resistor, which, as you can see, has got quite hot, and they break a connection on this big plug. Go on, give it a wiggle. But this one doesn't seem to be the case. Okay, so I've covered this up while I remove this. Screws here and here. Remember, on this boiler, you've got these catches here. Yeah? Okay, so still doing it. Got the 3 screws out on the bottom here. Still got one in the top there. The other 2 are out. So has it made any difference? Okay, so on here we have the main PCB, the gas valve. This, I believe, is to do with modulation. And this lot here is the fan, air pressure switch, and this other sensor. The fan is running. So very, very carefully I'm going to try and interrogate that switch there and see if that could be causing our problem. That switch there, by the way, is some sort of flue overheat, is what it looks like. I haven't actually checked, but that's exactly what it looks like. There may even be a separate fault code for that. If there is, then you can eliminate that. If there's a separate fault code to say that switch isn't working, you can eliminate that switch from what we're doing here. Right, so let me show you some other stuff on here. If you look down the side of this connector here, so you see PNC, PNO, PCF, got PC, fan, N, TS, TS. So PNC, PNO and PC is the air pressure switch. We have fan, neutral for the fan, and TS, which is that thermostat. So let's start testing. We know we've got 240 to the fan, so let's prove that by testing across that fan. Okay, that's the fan, live and neutral. 240. So this is the air pressure switch. Common, I believe. I'll check that in a sec. 240. So let's have a look at the air pressure switch. Oh, it's not. Common on the air pressure switch is actually black. Okay, so using that neutral there, AC on my thing. Now I'm going to do some tests on the air pressure switch wires, which are them 3 there. Okay. Brown. It's neutral. 240. Okay. That brown is normally closed, so that shouldn't have 240 on it right now. Next. Normally open. 240. Everything has 240 from the air pressure switch. Everything. So let's find out where the 240 is coming from. Is it coming from a faulty switch? Or is it coming from the faulty board? Let's see. Yeah? It's coming from the PCB. So the reason the boiler doesn't run is because this wire that's meant to have nothing on it has 240 on it, coming from this PCB. So it's this PCB once again. Power off. That was disconnected. So if that's, it could be something logic level, and that sensor there, when that doesn't have continuity through it, this PCB may stop sending power, or may short a 240 volt rail to the normally closed on the air pressure switch, which would in theory mean the boiler would, on a logic level, think the air pressure switch hadn't opened, which means it wouldn't fire. So it could be something like that, but I can test that quite easily with a multimeter. That's not that. Right, so I've linked that out on the board just in case this stat is causing the problem. So what happens is the boiler gets nice and hot, the stat breaks the electrical connection across the two wires here. Hold on, let me get to focus. There you go. The stat breaks the electrical connection across the two wires, and that then makes this board go to fault. And then the board stays at fault until you turn power off and turn it back on. That could be what's going on here. So if I can get the boiler to fault with that linked, because this is intermittent, this fault, but if I can get it to fault with that linked out, I've guaranteed that there's nothing else on this circuit board. Let's go wide. Guaranteed there's nothing else on this circuit board that will cause that issue. So, and just so you know, I'll show you how I've repaired the other bit. Not the best. It's more than satisfactory for the purpose it was designed for. So let's see what happens with it. I'm just going to turn the hot tap off and turn it back on. Hot tap off. Hot tap back on. Don't know if you saw the little red light came on there to signify the hot tap running. I'll do that again because it's actually worked. Red light went off. So what I'm going to do now is just leave this hot tap running. If I have to leave it running for 20 minutes, I will. I have to make sure, I have to know whether this boiler is still going to go to fault or not, because that's going to determine the actual part that's needed. So I'll come back to you if it ever goes to fault again. So I slowed the tap down, flame's gone out, boiler's got a relight, fan's running, it relit. We'll see. So while I'm waiting for this boiler to lock out or not, I just need to make something clear. You don't put links across blue and brown cables ever unless you're absolutely sure you know what they are. Because obviously if that was a live and a neutral, I would have just fried that PCB. Okay? You need to be 100% sure you know what that is before you do it. I know that's low as well. Damn it, it's working now. I'm just going to give it another 15 minutes or so. If the boiler doesn't go to full, what I will then do, which I don't recommend anyone does, I'm going to pull the link out live when potentially that might be at full. So the boiler's clicking on and off nicely at the moment anyway. Thing is just working at the moment, very frustrating. Okay, so the boiler continues to work. So what I decided to do, was some tests with it running. So that is the connection that normally closed on the air pressure switch. So we have 240 on that and the boiler works. Okay. Obviously I've taken that link out now across here. Alright, that is that recuperator sensor, or the flue sensor. That's got 240 on it now. That didn't have 240 on it when it wasn't working. Okay, and here's the neutral for that, which isn't a neutral. It's not a neutral. Okay, so we've got 240 across that. Now if we were to go across them both, like this, let me grab, hold on. So, now measuring across them both, we have 0 voltage. This is quite important for you to know. Although that comes up as 0 voltage, there's still 240 volts there. If you touched it, it would hurt you. Okay? Because what you measure with a multimeter is potential difference. So you're measuring the difference between the red probe and the black probe. Okay, so here, because they're both 240, because it's not actually a neutral, although it's marked up very like one. They could be 2 black wires, really. That would be the best solution in terms of safety for us guys. Anyway, so look, test across them, you have no voltage. So that's in there with the neutrals. 240, and we go on what is a neutral colour, 240. Okay, so there's 240 volts on both of these wires. Now when this wasn't working, there was no voltage here. We weren't getting the voltage out of this one, and that voltage comes to this via this circuit board. So again, that points to this circuit board being the problem. So we can also reference, we can test that to the earth as well. So you always, when you do your safety checks on boilers, you always reference earth with your testing as well, like that. Because if your neutral's out, you'll still pick up the voltage using the earth. I mean, if both are out, you're screwed, but there we go. So we 240 again, and 240 again. Reference to earth. So the difference between the red probe here and the black probe there is 240 volts. That's how multimeters work. That's why when you test across them both and the black probe is on a 240 volt supply, whereas on the 240 volt line you get 0 volts because the difference is 0. That's quite an important thing to know. Anyway, I'm ordering that board. I cannot prove it isn't that board, so that's what I'm going to order. I've tried everything I can think of to make it be something else, but it is that board, and it usually is that board on these boilers. Even when they don't have the Fluke stat, it's that board. Okay, so tune in next time to find out whether this Biasi gets fixed, and if it was the board that was causing the problem. Thanks for watching.